So radical equations, yes, I always get these mixed up because the word radical and rational are so close to each other. I think that was part of my problem yesterday when I had the wrong worksheet for a little while. That I always get them mixed up. I mean, I know them very well, but still when I look at them, I get them mixed up. So radicals are ones with roots, square roots, cube roots, fourth roots, etc. You can write that down if you would like, but this part right here, I definitely want you to write down. When solving radical equations, you sometimes get what we call extraneous solutions. These are solutions that do not work in your original equation. And those we have to check for. So that I would highly encourage you to write down. So we have seen extraneous solutions before. I may or may not have called them that. Whenever we were doing rational equations, sometimes we would get an answer like x equals 1, but when you plugged 1 back in, it gave you a 0 in that denominator. So you had to check that as well. But extraneous solutions are not that common with rational equations. They are very common with radical equations. So it's going to be really important that we check our answers on these. Ever since you were in like Math 1 and first started learning to solve an equation, really even 8th grade math, they told you to start like to plug your answer back in to check. And how many of you, when you solve an equation, plug your answers back in to check today? I would say probably not many of you because it takes a lot of time, especially the harder the equations get, right? But you have to do it on these because there are a lot of times that you get extraneous solutions when you're dealing with square root functions. Our first easier ones that we're going to do, we're not going to see it happen often, but as we get to the harder equations, you're going to see it happen more and more. So let's look at what we're dealing with here. So I've got a couple of equations right here as our first couple, and I am going to put these up here, and I want you guys to solve these because I bet you probably already know how to solve these. Maybe. walk around. I'm seeing several of you with the correct answer for number 1. Correct answer for number 1 is 38. Seeing several of you get that. I don't know that I saw anybody that had the exact correct answer for number 2. Maybe. Anybody think they got the right answer? Who have you got, Brayden? Oh, Brayden's got it. I didn't look at his close enough. Several of you had 2 root 7, but not the plus or minus with it. So let's look at these real quick here. So whenever we have a square root, the inverse of a square root is a square. So we're going to square both sides of the equation here. And so to square both sides of the equation, it's just going to cancel out the square root over here. I think I saw a couple of you that were like getting x squared minus 4x plus 4 here. You were squaring what's inside of that. You don't. It just cancels out that square root. So x minus 2 is going to equal 36. And then all you have to do is add the 2 to the other side. Now, you do always want to check your answers here. I'm not going to require you to write it down, especially on a problem like this, because you can probably do this in your head. Square root of 38 minus 2 is the square root of 36, which of course equals 6, which is what it's supposed to equal. So that lets you know that that answer is okay. Especially on these easier ones, they're going to be pretty easy to check in your head, but you do always want to think about plugging these back in. And especially on these easier ones, I can't remember if I gave you one where there is an extraneous solution. I know we'll have some when we get to the more difficult questions. But let me just really quickly show you why we have to check. Let's say that this equation was square root of x minus 2 equals negative 6. Okay? Now, can a square root ever equal a negative number? It cannot, right? Square root of something cannot be a negative number. But if we solve this equation, if we square both sides, we're going to get x minus 2 equals 36. We will add 2 to both sides, just like we did before, and we'll get x equals 38. But if we plug that back in, 38 minus 2 equals negative 6. Square root of 38 is 36. That's never going to equal negative 6. It's going to be positive 6. So that would tell you that that's extraneous, and you would have no solution or empty set there. You would not have an answer for that one. So I can't remember if I put another one like that on this first part of the notes. I just wanted to explain why we have to check our answers there. Because the nature of squaring both sides of the equation gets rid of negatives that were there. So it sometimes creates solutions that don't actually work in your equation. So you have to check for those. All right, questions on 1? All right, on 2, the inverse of a cube root is a cube. So we would cube both sides, which is going to give us x squared minus 1 equals 27. We would add 1 to both sides here, giving us x squared equals 28. And then to get rid of that square, we're going to square root both sides. Whenever you square root both sides, you have to put a plus or minus. So you get plus or minus square root of 28. And 28 will break down into 2 square root of 7, which I was impressed that there were 4 or 5 of you that had already broken that down into 2 root 7. So I was impressed with that. A lot of times we avoid breaking roots down. That was good. All right, to check that one, when I check these, I don't use 2 root 7. You can, but it makes it a little more difficult. I use square root of 28 because we've got cube root of the square root of 28 squared minus 1. So square root and square cancel each other out there, and you don't even have to think about it. Whereas if you did 2 root 7 squared, you'd have to square the 2, which would be a 4, square the square root of 7, which would be a 7, so that would give you 28. Works out the same way. You just have to be careful with it. So you got cube root of 28 minus 1, which is the cube root of 27, and the cube root of 27 is 3, so you know that that worked there. It would also work if this this 28 square root of 28 right here was negative, because when you square that negative square root, it becomes positive, so you'll get the exact same thing. Okay, questions? All right, here's our next one. So these are a little different than the first ones because your root is not by itself. So if you have a problem like this, the first thing you want to try to do is to get that root by itself. So we got to get rid of this 2. We got to get rid of that minus 20. We want to deal with that minus 20 first. So we're going to add the 20 here. So we got 2 times the 4th root of x squared plus 1,000 equals 20. We're going to divide. I don't know why I put 10. Divide by 2, because that 2 is multiplied by that root there. So we got the 4th root of x squared plus 1,000 equals 10. All right, how do we get rid of a 4th root? 4th power, right? So 4th power on both sides, those two will just cancel. We'll get x squared plus 1,000 equals 1, 2, 3, 4 zeros there. And we will subtract 1,000, which is going to give us 9,000. And 9,000 is not a perfect square. 900 is. So this would be 900 times 10. Square root of 900 is 30. Root 10. Do that right. Make sure. Yeah. What did I forget? Plus or minus. Where I square root both sides, you have to put that plus or minus. You do always want to check these. So 2 4th root of, I'm just going to go square root of 9,000 squared plus 1,000 minus 20 equals 0. So you got 2 4th root of square root of 9,000 squared is 9,000 plus 1,000. And so 4th root of 10,000, which is 10, and 20 minus 20 does equal 0, so you know that that works. You're welcome to check this in the calculator, especially whenever you're doing this on your homework. There's a chance. I can't remember if I give, I think, this doesn't necessarily mean anything right here. I think I usually give this one on paper. I think that I let you use the calculator on the whole test on this one, but you have to show work for the whole thing. And I think I just let you use yellow calculator, not Desmos, because Desmos makes things too easy if you just graph it and see where they cross. So you'll be able to use your calculator to check on these. Again, the work to check is not required, but you do have to check because sometimes you're going to get extraneous solutions, which I've been promising that may not happen in this first part. Okay. Here is our next problem. So we've got the square root of 6n minus 3 equals the square root of 4 plus 7n. I've got square roots on both sides. There's nothing on the outside of either one of those square roots. So these are going to be fairly simple problems because if I square this side and square this side, which I can do, it's just going to cancel my square root. So I just have 6n minus 3 equals 4 plus 7n. And so now you're just down to a basic equation. You're going to subtract that 6n. And I'm going to go ahead and subtract this 4 right here to move it over here. So I get negative 7 equals n. Now, you do always want to plug this back in to check to see if it works. So you got 6 times negative 7 minus 3 equals 4 plus 7 times negative 7. And so we got negative 42 minus 3 equals 4 minus 49. So we get square root of negative 45 equals square root of negative 45. So does that one work? I feel like yes, but I specifically put this one on here because either this question or one just like it is in the textbook that we used to use for pre-calculus, and they say this does not work because we've got negatives under the square roots here, and you can't have negatives under the square root. So in the textbook, they say it's no solution. And I guess I'm going to go with what they say because I feel like the people that wrote a textbook and were a textbook that was accepted by a major publisher probably know more than I do to have a better argument for that. I a little bit in my heart feel like negative 7 should be okay because although these are imaginary, they do equal each other. But in the textbook it says it's no solution. Due to the fact that I feel like there should be, this is a little bit of a gray area for me mathematically. I don't totally accept their answer that they've given here. I'm not going to give you one like this where they do equal each other, but you have a negative under the square root. I'm not going to give you that on a quiz or a test. You might see it in some of the assignments that we look at possibly, so I wanted to introduce it, but I probably won't give it on a quiz or a test because I feel like there's argument to be had there that these actually, although they're imaginary, do equal each other. So, but I wanted to throw that one out there. All right. Okay, we're going to stop for a second because with example 5, these problems get a little bit more. Negative 10 square root of v minus 10 equals negative 60. What do we need to do first on that one, Blaine? Not add. That was where your mistake was. So if it's right next to that square root, it's been multiplied. With that negative makes you think add, but you're going to divide that negative 10. So that's going to give you the square root of v minus 10 equals 6. And now you'll square both sides. V minus 10 is 36. Add 10. to get that 46 that we said there. You probably had a much bigger number where you'd added that 10 instead. So be careful if it's right next to it, you're going to divide. Now, if you had something like this, negative 10 plus the square root of e minus 10 equals negative 60. That's when you would add it. And other ones that we need to look at? Okay. When we pick back up with those notes, we're going to do the second part of the notes, and we're just going to go as far as we can get today on those. We'll also work on this on Monday, so if we don't finish the notes today, we'll finish on Monday. So that means you won't have any homework this weekend. Don't tell anybody, or I might lose my title. So I don't want somebody like Miss Rory coming by and beating me out for that. So homework queen is the only thing I got. So so we've got a situation here where we got square root of negative 16 plus 10a equals 8. This doesn't look a lot different than the last problem we saw, but there's going to be something about it that makes it quite a bit different anyway. And so if this a right here was a 5, then it would be exactly like the ones you've just done. But on the ones we've already done, we had a number right here. We do not have a number right here. We have a letter. So when we square both sides on this equation, we're going to get negative 16 plus 10a. The square root still just cancels on that left side. And that's going to equal a squared. So I have an a squared and also a 10a. So what do I do to solve this? Factor. So we'll move everything to one side. We're going to factor. So I'm going to move everything over here with the a squared. I like for it to be positive. So I have minus 10a plus 16. So if we factor that, we will get minus 8 minus 2. I think that'll work for us. So we end up with a equals 8 and a equals 2. And we do always want to plug these back in to check. So if I think of plugging these back in to check, and let's just shortcut this a little bit. I'm going to use the calculator. I'm going to even do this. I hate plugging my answers back to check. I never do it. I feel confident in my ability, so I don't do it. But you have to on these, because even if you did it right, sometimes there's incorrect solutions. So I hate for you guys to have to spend a long time checking. So let me show you this on, so I remember how to do it. I do this. That's it. All right, and then so like if you want to do this really quickly on Desmos, I put in one of my answers at first, a equals 8, and then I've typed in one side of the equation, square root of 16 plus 10a, and it's plugging in the h for the a for me there, which you could do this in your head pretty easily. Negative 16 plus 10 times 8 would be 80. 80 minus 16 would be 64. Square root of 64 is 8. And then the other side of the equation is just a, so that also equals 8. So since these are equal to each other, then 8 is the correct answer. So, but what's nice about this when you have more than one answer is rather than redoing it, you just go up here and change that 8 to a 2, and it'll do the same thing. So since these two equal each other, then both of these are correct answers for this one. So that's just a little shortcut for checking. I'm probably not going to let you use Desmos on this test. It's probably going to be the yellow calculator, so you have to plug it in. But to speed it up a little bit on homework, if you want to use that, that's fine. So both of these are answers for this problem. Okay, questions? That's the one I'm just going over. All right, here's our next one. Okay, so for this one, we've got x plus 6 underneath the square root equals x plus 4. And this is quite a bit different than even the last problem because I've got an x and a 4 here. So I got two things over here, and I can't combine it with anything, right? I can't put the x and the 4 together. I can't subtract that 4 because this 6 right here is underneath the square root and the 4 is not. So I can't do anything to combine these. So what we're going to have to do is we're going to get the square root by itself if it's not already, which it is by itself here. We're going to square it. That'll at least get rid of our square root. So I got x plus 6. But that means I have to square the other side. And when I square the other side, I have to put parentheses around it and square that entire expression, which means that I'm not doing x squared plus 16. I'm doing x plus 4 times x plus 4 here. So I've got to do my square double square there. So it's going to be x squared plus 8x plus 16. So you can use that shortcut we've been using quite a bit where we square, double, square. So square the first, it gives you x squared. Multiply these together. X times 4 is 4x. Double it, you get 8x. Square the last, you get 16. Then, or if you want to, you can distribute over here, but it'll take a little bit longer if you do that. So now I have this expression that is a quadratic, and I also have this x plus 6 over here. So it's like the last problem when you move everything to one side and factor. So I'd subtract that x and subtract that 6. So 0 equals x squared plus 7x plus 10. And that is going to factor for us into x plus 5, x plus 2. So we will get x equals negative 5 and x equals negative 2. Okay, questions? All right, we're not done because we haven't checked our answers. So I'm going to use Desmos just because it's so nice. So I'm going to use an A again instead of an X. It might not do, I don't think it'll do it right with an X because if you tell it X equals, it's trying to graph it rather than just letting it be a variable. So I'm going to say A equals negative 5. So on that left-hand side, I've got square root of A plus 6, and on the other side, I got A plus 4. Now, do those equal each other? If I plug in over here, I get a positive 1. If I plug in on the right-hand side, I get a negative 1. So this is not an answer. This is what we call, what we call that extraneous solution. Alright, so it's not an answer. We would mark it out. Hopefully, -2 is going to be an answer. And you can see, when I change that to a -2, both of those equal 2. So that does work. Alright, questions on that? This happens a lot, especially when you have two answers. It happens really often that you have two answers and one of them is extraneous. Now, sometimes, like the last problem, you'll have both of them are both correct. But a lot of times, one of them, if not both, are extraneous. Now, if you're getting both solutions extraneous a lot, you're probably doing something wrong. And the reason when you plug them back in that they don't match is because you solved it incorrectly in the beginning. But you will see this happen a lot, so you need to make sure that you check for that each time. I can't stress how important that is because I know that there's probably many of you out there like myself that it is an annoyance and a burden to have to check it there at the end. But you have to. Alright, so let's look at what we've got here. Okay, I'm going to let you guys try this one on your own, actually. Try this one on your own. So you should get 2/3 and -8 for this, although I have not checked for extraneous solutions yet, so one of those may be extraneous. When you square this over here, make sure you got 25 plus 20x plus 4x squared. There, and over here this will just cancel. You will move everything to one side, so make sure I've done that right. 3x squared. Oh, it is positive. Being positive ruins my plan, though. It's not going to factor if I've got a positive, is it? Can it? Ugh. 6 and 4. 6 here, 4 here. Okay. Ignore what I had done before. Let's try again. 3x would equal -4. So x would equal -4/3. And over here, x plus 6 equals 0. So x would equal -6. Always better. Okay. I'm pretty sure -6 is not going to work. I can tell that because if I plug in -6 right here, I got 5 plus 2 times -6, which is going to give me a negative number, and that square root can't equal a negative number. But let's just double check with the 4/3 might work. It might be small enough. So I'm going to do -4/3. This is especially helpful whenever you got those fractions, so you don't have to plug those in. You can see -4/3 works. You're getting the same value there. But if we change this to a -6, we get a -7 and a +7. And those aren't equal to each other. So we would throw out our -6 here. And -4/3 would be our only answer. Questions? Alright, I am going to skip to the second part of these notes. And our last 15 minutes here, I want to see how good you are. You guys are a pretty smart class. I want to see what you can do with this. I will definitely teach you how to do this if nobody gets it. But I want to see if anybody can solve this. I better solve it to make sure I know what the answer is so I can tell you if you're right or not. I don't want to do that up here. So I want to see if anybody can get this, and if both sides, which some of you were trying to do, but nobody was doing correctly. So over here, it is just going to be x plus 10. That part, a lot of us were doing correctly. But over here, this is not going to be 25 plus 3 minus x or something. It doesn't just cancel that out. We have to write this twice. 5 minus the square root of 3 minus x times 5 minus the square root of 3 minus x. Which means that we're going to have to distribute, not like that. We're going to have to distribute, we're going to have to distribute here. It also means the square roots are not going to go away on this step. So you're still going to have a square root. So after you get this part done, it actually looks worse than it did to begin with. But then you got to try to get that square root by itself and square both sides. So you're going to have to square both sides twice on this problem. So I'll give you that hint and see what you can do from there. All right, let's check this next step. Okay. Actually, we don't have a lot of time. I'm gonna finish doing this, so make sure you're copying this down. We'll do some more of these, so I don't expect you to be able to do one of these on your own at the end of today. So x plus 10 just hangs out over here. 5 times 5 is 25, right? 5 times negative square root of 3 minus x. The 5 is not under the square root. The other stuff is, right? So we can't put those together. We just have to write them as a negative 5 square root of 3 minus x. So this is where those square roots are not going away on this. And then when we do the middle terms, we're going to get the same thing, right? Because we're doing 5 times negative square root of 3 minus x. So we'll have another minus 5 square root of 3 minus x. And then to distribute that last one, we've got to do negative square root of 3 minus x times negative square root of 3 minus x. Negative times negative is a positive. What do we get when we multiply the square root by itself? If I do square root of 3 minus x times square root of 3 minus x, that is like having square root of 3 minus x squared, which just gives you 3 minus x. So if you multiply square root, we knew this if we do like square root of 5 times square root of 5. We just get 5, right? It's the same thing even if you have variable expressions. So we get 3 minus x right here. I told you, it gets worse before it gets better, right? This looks like we've made the problem worse. But there are some things that we can combine here. And I got that 25 and that 3, so I could put those together to get 28. And then I've got this minus square root of 3 minus x, and the other minus 5 square root of 3 minus x. So since those square roots are exactly the same here, we can combine them and make it minus 10 square root of 3 minus x. And then I put that 3 with the 25, so it's there. I got that minus x on the end. So even though this looks horrible, it is a little bit better because we started the problem with 2 square roots and now we only have 1 square root. So we're headed in the right direction. So what we want to try to do now is we want to try to isolate that square root that's left and move everything else to the other side so we can square both sides again. So I'm going to add this x right here and subtract that 28. I can't deal with that 10 yet because it's multiplied there. So I'm going to have 2x minus 18 equals negative 10 square root of 3 minus x. Now that negative 10 right there is multiplied by the square root, so I could divide it off. But if I divide it off, does it go evenly into 2 into 18? No, which means I'm going to have fractions. And if you are like most students, you should have a natural aversion to fractions where you would rather not have them, right? So a way around that so that you don't get fractions is to just go ahead and square it right now. Now, if it would go evenly, divide it. It'll make it easier. But sometimes it does not go evenly, so we're going to square both sides. So when I square this over here, I've got a square double square. So 2x squared is going to be 4x squared. Double 2 times 18 is 36. If I double it, I get 72. And then square the last, that's 324. I won't give you one of these without a calculator. Not this big of numbers anyway. And then when I square this, I got to square that negative 10, which is going to be a 100. And I got to square the square root, which will cancel the square root. So I'll have 3 minus x, but make sure you put that in parentheses, because that 100 is going to have to be distributed to it. And I'm running out of time. I'm going to go super speed here. You can pack up as you're watching if you want. So we would subtract 300, and we would add 100. I know you might not have time to write this down. We'll do some more of these on Monday. Plus 28 plus 24 equals 0. If you divide everything by 4, you'll get x squared plus 7x plus 6 equals 0. That factors into x plus 6, x plus 1. You're going to get x equals negative 6 and x equals negative 1. But negative 6 doesn't work. It's extraneous. We'll do some of these all the way on Monday. These are ones definitely to go show your mama whenever you get finished. I love them. They're great. I also like that you couldn't already do them whenever I gave them to you. Because